Welcome to direct and inverse variations. This topic is number 14 in Richard James Mathematics Resources. Direct variation is being used by mankind to solve many of the greatest problems. The comparison between two variables that closely approximates to a straight line is always welcome because of its ease of use. Such a comparison is classified as direct variation. The approximation to a straight line is so desirable that mathematicians have used transposition and other algebraic manipulations to give rise to linear relationships where they would not otherwise exist. One of the most common examples of this is inverse variation. An inverse variation graph turns out to be a curve when one variable is plotted against the other. Because of the comfort afforded by a straight line, one variable is plotted against the inverse of the other, resulting in a straight line graph. Direct variation. If a variable y is dependent on another variable x, and when x increases, y also increases, then there is a direct variation between x and y. In this event, y will decrease when x decreases. The mathematical way of saying it is y is proportional to x, so we have more than one ways. Y varies directly as x, or y is directly proportional to x. Y varies directly as x is symbolized as follows. And this is this symbol that we use to represent proportionality. The direct variation is a straight line. We have studied the equation of a straight line, and one of the most important ingredients in its formula is the gradient. The direct variation is therefore written as the equation of a straight line in which k is introduced as its gradient. Another name for k is the constant of proportionality. If a variable y is dependent on another variable x, and when x increases, y also increases, then there is a direct variation between x and y. In this event, y decreases when x decreases. If a graph is drawn depicting y against x, a straight line graph will be the result. So we will have our y-axis and x-axis, and if we are going to show the plot of y increases as x increases in a linear way, then this is how we will do it. And the equation is y is equal to kx. When solving a problem involving variations, the value of the constant of proportionality is determined first. Its importance is right up there with the regular gradient of a straight line. If 10 bags cost $45, how much do 14 bags cost? The other part of the question says, how many bags can $130.50 buy? Sometimes a question does not declare itself to be a direct or inverse variation. This is left up to the interpretation of the student. This one is straightforward. If bags or any article is being bought, the greater the amount of money available, the more bags that can be purchased. There is no great problem seeing that this is direct variation. So if you increase the number of bags, you'll have to increase the amount of money that is used to purchase them. And if you have a small amount of money, then you are sure that that amount of money will purchase a smaller number of bags. So we know that we have a direct variation. Now we are going to use C to be the cost and B to be the number of bags. Write the relationship between C and B. Now, in a direct variation, C is equal to KB. It may also be written in the reverse, where B is equal to KC, where K is the constant of proportionality. The answers that we'll get from the expression will be the same. So it says 10 bags cost $45, and we have it highlighted there in this exercise, we are going to be highlighting the statement that we are going to be using to construct our algebraic relationships. So, because 10 bags cost $45, we have an equation here, and k is the only unknown. So we're going to determine the constant. That is what we usually do first. We usually determine the constant first, except in the case that we'll see a little bit later on when we'll be using another method to solve a problem involving direct variations. So by transposition, find the value of k. Of course, 10 is going to be transposed to the other side. We're going to be dividing. So 45 divided by 10, that is k. So k is equal to 4.5. K is equal to 4.5 and b is equal to 14. And we need to find the value of c. So here we have how much do 14 bags cost. So we have the value of the constant and we have the number of bags. So all we need to do now is to determine the cost. Put those in, substitute the known values in the equation. So k is 4.5 and the number of bags is 14. No problem, just multiply 4.5 by 14 and c is equal to 63. So that is $63. In the other section, how many bags can $130.50 buy? Of course, we have the constant. We know already that it is 4.5. We have calculated it earlier on. And we have the cost. So all we need to determine is the number of bags, which is b. So let us substitute the known values that we have into the equation. Yes, c is $130.50 and the constant is 4.5. So in order to find b, we are going to transpose the 4.5 to the other side. It is multiplying by b on the right, so we are going to divide by that on the left. And then reversing the situation, we have b is equal to 29. So that's what we are going to have, 29 bags. Sometimes students ask me, what is the real meaning of the constant k? In this particular case, it represents the cost of one bag and may mean something useful in other cases. However, in most cases, it is not referring to anything that is tangible. We have another problem. Y varies directly as x squared. If y is equal to 45 when x is equal to 4, find x when y is equal to 75 and y when x is equal to 3. What do we do first? We write our relationship. May remember that it is a direct variation, so y is equal to some constant times x squared. That is always, that's our general form for a direct variation. Find k by substituting the initial values of x and y. So we're going to find k first, and we have initial values of x and y here. Y is equal to 48 when x is equal to 4. So y is 48 and x is equal to 4. So by transposition, what do we have? And of course, 4 squared is equal to 16. So 48 divided by 16 is equal to 3. K is equal to 3. We have highlighted here. Find x when y is equal to 75. Of course, we know the constant and we know the value of y. So we're going to use the same expression that we had before. And k is equal to 3, y is equal to 75. So y, we are going to substitute first. And we get the values. Y is 75 and k is 3. And we do not know x. Transposing by dividing by 3 on the left-hand side, 75 divided by 3 is 25. And we have x squared. In order to find x, we have to do the square root. So x is equal to plus or minus 5. Positive or negative 5. Usually in direct variation, we just use positive 5. But do not forget that a number has 2 square roots. Here we have k is equal to 3 and x is equal to 3. Find y when x is equal to 3. That's what is highlighted there. So We do not know the value of y. We know the value of k and the value of x. So we're going to substitute those into the equation. That's all there is to it. Problems of this nature sometimes request only the positive square root, and the negative one can be discarded. Do not forget that the square root of a number, when it exists, it occurs in pairs, one positive and the other negative. A man called me on the phone and was trying to determine if I am a mathematician. And he gave me a trick question that requested the square root of 144. I said that I did not know, and he said that I should be ashamed of myself. He boastingly said 12. He almost crucified me when I told him that the answer is a positive or a negative 12. That is our problem. Y varies directly as 2x plus 3. When x is equal to 4, y is equal to 66. So find y when x is equal to 10, and find x when x is equal to 198. Find k by substituting the initial values of x and y. Remember that when we are writing a direct variation, we say y is equal to the constant of proportionality multiplied by the other one. That is if we are dealing with x and y, or whatever variable that we are using, one is equal to some constant multiplied by the other. Now in this case, it is proportional, or it varies directly to as 2x plus 3. So 2x plus 3 is multiplied by k, and we need to include the entire 2x plus 3. So we need to put that in bracket in order that k is shown to be multiplying the entire expression. Now we need to find the value of k, so we are substituting the values that we have there, the initial values. X is 4 and y is 66, and then we are going to solve this problem. So 2 times 4 is 8, plus 3 is 11. So if we are going to transpose now, what will we get? 66 over 11 is equal to k, so k is equal to 6. K is equal to 6, x is equal to 10, and we need to find the value of y, because it says find y when x is equal to 10. So substitute the known values in the equation. Remember, k is equal to 6 and x is equal to 10. So all we need to do is just substitute this. So 2 times 10 is 20, and that is going to be 23. And then we're going to multiply 23 by 6. So y is equal to 138. What do we do next? As highlighted here, find x when y is equal to 198. And of course, the constant is 3. So all we need to do is find the value of x, which is the only unknown in the equation. So we substitute into the equation. So there we have it. Let us see what we do first. We get rid of the 6 that is on the right hand side by dividing by 6 on the left hand side. This 6 is being multiplied here, so we divide on the left hand side. So that turns out to be 33. So now 33 is equal to 2x plus 3. We have a positive 3 here. We're going to be transposed to the other side. So it's going to be 30. We're going to say 33 minus 3, which is 30. We are multiplying by 2 here, so we're going to divide by 2 on the other side. So x is equal to 15. We may take another approach to direct variation by using ratios. In this case, we will not be required to determine the value of the constant k. When working with ratios, we must be sure that the variable that is used as the first number in the ratio must always be the first. So that is our first problem. And of course, we're going to write the ratio c to b. It is the same problem, so the symbols are representing the same thing. So c to b. And of course, if we're going to be putting the cost first, we need to put the cost and then the number of bags. So let's see what the next statement is. In all subsequent ratios of this problem, the value of C should be the first number. Place the known value in a ratio. So place the known values in a ratio. It says here 10 bags cost $45. The cost is the one that is here first. See? Cost to the number of bags. So the cost is placed here first. 45 is placed there and the 10 is placed next. So the question is, how much do 10 bags cost? Write another ratio with B is equal to 10. So the number of bags for 14, the number of bags is equal to 14 and the unknown cost C is unknown. And of course, C is going to be placed in the ratio first. So the cost goes first and the number of bags goes next. All the time, the cost goes first and the number of bags goes next. The initial thing is 45 to 10. And again, the next ratio is the cost to the number. Now we have two ratios. So we are going to write them as fractions and equate them. Write the ratios as fractions and equate them. So there we have it. By transposition, we have C is equal to 14 times 45 to be divided by 10. And C is equal to 63. I hope that no one forgets how to write ratios as fractions. How many bags cost $130.50? So this is our original ratio. It gives us the initial values. And the other one says the cost is $130.50 and we do not have the value of B. The cost goes first in the ratio, so we're going to have the cost to B. So $130.50 to B. And of course, we're going to write them at the two ratios as fractions and equate them. And we are going to solve the equation by transposition of formulae. So the other problem that we solve is going to be done by using ratio also. So we're going to write the ratio y to x squared. We cannot write y to x because y is not said to vary directly as x. Y varies directly as x squared. So we have to write y to x squared. So we are just writing this thing. We're not going to be using it in our calculation. What are we doing? Why are we doing this? To show that we are going to put y before x squared all the time. So y is 48. It goes first when x is equal to 4. 4 squared. Do not forget that the variation requires not x, but x squared. So find x when y is equal to 75. What do we do? Y is 75 and we do not have x. So we're going to have the ratio 75 to x squared. Remember that the value of y is placed first. Now we are going to write these two ratios as fractions that we have right here, and we equate them, and we're going to solve the equation by transposition as usual. Our first step in transposition that we use this time is the one that we have learned of old that says if the proposed subject is in the denominator and we have two fractions that are equal, invert the two fractions and they are still equal. So that's our first step. Then we're going to multiply by 75 on the left hand side, and we have 25 is equal to x squared. Of course, x is equal to the square root of 25, which is a plus or minus 5. So we need y when x is equal to 3. So write another ratio in which x is equal to 3. Of course, we are writing our initial ratio here, the one that has the initial values. And of course, y goes first, and the square of the x value, which is 3 in this case, goes next. And we're going to write the ratios as fractions as usual. We are going to equate the fractions and solve the equation. And y is equal to 27, which is what we had before. So ratios can be used irrespective of how the direct variation is written. That's another of our problems. And what do we do in this case? Y varies directly as 2x plus 3. So we're going to have the ratio y to 2x plus 3. When x is equal to 4, y is equal to 66. So 66 to, of course, 2 times 4 plus 3. We have substituted the value of 4 in this expression, 2x plus 3, so we cause x to be equal to 4 in this expression. And that's our initial one. So 66 to 11. So find y when x is equal to 10. So this is what we're going to be using, 66 to 11, to find y when x is equal to 10. So we're going to have what? Write another ratio, y 2. And of course, the x value is 10, so we substitute the 10 into this initial expression that we have there, and that is what we have on our right-hand side. Of course, we are going to, as usual, equate the two ratios. So we're going to write the ratios as fractions and equate them. And we're going to solve the equation, and we get y is equal to 138. And we are going to do the other part. Find x when y is equal to 198. Our initial ratio is 66 to 11. The y is on the left-hand side, and the expression with the x is on the right. And we're going to do the same thing when y is equal to 198. So we're going to have 198, and we are going to have the expression 2x plus 3, in which, of course, x is the unknown. And we're going to write the ratios as fractions and equate them. And then we are going to continue to transpose in order to determine the value of x. Let's look right here. No problem seeing how the ratios are written as fraction. The first number is the numerator and the second is the denominator. And here we have the first number here is the numerator. We may not say number, we may say expression. So the second expression here is the denominator. And what do we do here? We invert, because the proposed subject of the formula is in the denominator. So we invert first, and then we have 198 here. We are dividing by 198, so we multiply by 198 on the left-hand side. And that is what we have right here. This turns out to be 33 when simplified, and that is equal to 2x plus 3. And of course, we have solved this particular equation before, and even if we did not solve it, we have solved a host of linear equations. So we should be able to write down this answer in one step. X is equal to 15. Now we are going to take a look at inverse variations. And of course, remember our direct variation. Let us see how closely it relates to inverse variation. If a variable y is dependent on another variable x, and when x increases, y decreases, then there is an inverse variation between x and y. In this event, y will increase when x decreases. The mathematical way of saying it is y is inversely proportional to x. We may say y is proportional to the inverse of x, or y varies inversely as x. The graph depicting y against x will be a curve that shows that the value of y decreases as x increases. Like that. In a graph depicting a variation, it is more convenient to get a straight line instead of a curve. The plot is therefore of y against the inverse of x. And the y against the inverse of x turns out to be a straight line. An inverse variation between x and y is symbolized as follows. Y is directly proportional to 1 over x. The equivalent equation may be written as follows. Y is equal to k over x. So y is equal to k over x. The graph of y against x is a curve. To get a straight line, the graph should be y against 1 over x. Why? Because if we write k over x, we may even write it as k multiplied by 1 over x. So the constant, which is the gradient, is right there, and we have 1 over x there. So 1 over x will be the other variable. So the other variable turns out to be 1 over x instead of x. The algebraic display shows that there is a linear relationship between y and 1 over x. Yes, so let's write it there. Y is equal to k multiplied by 1 over x. And of course, the equation of the line is y is equal to kx. Or y is equal to k times something. But what we are using in this event is 1 over x. So there's a linear relationship between y and 1 over x. Now, 20 men can complete a task in 15 days. How long will it take 30 men? And how many men will complete the task in 42 days? The question is not explicit on the type of variation. However, more hands make work lighter. With an increase in the number of participants, the time to complete the task will decrease. This is obviously an inverse variation problem. So this is an obvious inverse variation. Why? Because if you increase the number of men, the time to complete the task is going to go down. So in this case, we are symbolizing m as the number of men and d as the number of days. Write the relationship between m and d. And of course, remember how the inverse variation is written? M is equal to k over d, or one variable is equal to the constant of proportionality over the other one. So that's the general form of the inverse variation. So it says 20 men can complete the task in 15 days. It's highlighted right up there. And that's our initial, that's the set of our initial values that we are going to be using to determine the value of k. So the number of men is 20 and the number of days is 15. So no problem. By transposition, find the value of k. That's easy. K is going to be equal to 20 times 15, which is equal to 300. How long will it take 30 men? What do we know? We know the constant of proportionality is 300, and we know the number of men is 30. So we're going to put 30 here, and the constant is 300. So let's see. Substitute the known values into the equation, we get that. So what do? Just multiply by d on that side because we are dividing by d here. And at the same time, we may then divide by 30. So that transposition should not be any serious problem to you. So number of days, 10 days. How many men will complete the task in 42 days? So we know the constant of proportionality and we have a number of days. So what does that give us? When we substitute, that's what we have. M is equal to 7.1. We may not consider a fraction of a man, so let us use 8 men instead of 7.1. I declared earlier that it does not matter which side the variables are on, as long as the relationship between them is properly expressed. In the previous problem, I placed the variables on opposite side of the equation to the one that I have in the accompanying booklet. So if you look in the booklet, you will discover that the variables are not on the same side as I have them on this slide. the answers turn out to be the same. So it really does not matter which side the variables are on, as long as the initial algebraic expression depicts an inverse variation. In this particular case, and when you are dealing with direct variation, it should depict a direct variation. Notice that the answer turned out to be the same. The answer that we got in the booklet is the same as the one that are presented on this slide. The answer to the question gave 7.1 men. I hope that no one can imagine 0.1 of a man at work. On seeing the fraction, one may opt to round the number off. What is wrong with this? If we use 7 men, let us see how long this will take. Using the same relationship, and we are trying to determine the number of days. The constant is 300, and the number of men is 7. Transpose, we get 42.9 days. No problem with 0.9 of a day. 9 day is a continuous variable, so we may have any fraction of a day. There is nothing wrong with a fraction of a day. The number of days is a continuous variable. In this problem, the number of men is a discrete variable. When a time constraint is involved, work must be completed in or before the time allotted. Nothing is wrong if the time is less. When it takes more time, we may have a serious problem. One may want to move on to another assignment the following day. It may be very costly to move equipment on site for an extra day, or the pitch may need to be prepared for the game that was scheduled to begin tomorrow. 8 men will take 37.5 days, which is a few days less than the 42 required. This is acceptable as the work will be finished within the time allotted. So no problem if the time allotted, if we, by doing our rounding, the number of days decrease. But there's going to be a serious problem, because when work is given to a team, it is expected that the team complete the task in the time or before the time. So we cannot use 7.1, because we cannot use 0.1 of a man, and at the same time we cannot round off to 7, because that will cause the time to be greater than the time that was allocated for the job to be completed in the first case. Y varies inversely as x squared minus 1. Y is equal to 15 when x is equal to 3. Find x when y is equal to 5, and y when x is equal to 2. So we're going to write the relationship between x and y. And of course, remember how this is done. Inverse variation, so one variable is equal to the constant of proportionality over the other variable, or in this event we have an expression x squared minus 1 that we are going to use. Find k by substituting the initial values of x and y. Of course, after substituting, just 3 squared is equal to 9 minus 1 is equal to 8. So multiply 15 by 8. K is equal to 120. After finding the value of k, we are required to find the value of x when y is equal to 5. So we are going to be using the same initial expression that we have, and we are going to take the same approach, substitute the known values in the equation. What do we know? We know what the value of y, but we do not know the value of x. Right? And then what? Multiplying by x squared minus 1 on the other side requires that we multiply 5 both by x squared and negative 1. So 5 times x squared is 5x squared, and 5 times negative 1 is negative 5. We continue to transpose. That's our situation. And we have x is equal to plus or minus 5. So k is equal to 120 and x is equal to 2. We are going to find y when x is equal to 2. Substitute into the equation. So y is equal to 120 over 2 squared minus 1. Y is equal to 40? No problem. We are going to use ratios in our inverse variations. Now, before we use ratios in inverse variation problems, some workings with fractions need to be clarified. So we're going to clarify something. So we're going to consider the following ratio: m to 1 over d. Like any other ratio, it may be written as a fraction. And of course, how the fraction is written? The first number in the ratio is the numerator, and the second expression is the denominator. And that turns out to be 1 over d. Of course, when we divide by a fraction, we invert and multiply. So that is what we have done right here. So it turns out to be md. And that is what we need to be cognizant of. If we are going to be using numbers and we have a ratio 25 to 1 over 7, 25 to 1 over 7, we are going to say 25 to be divided by 1 over 7. And of course, when we divide by a fraction, we invert and multiply. So we are going to have 25 multiplied by 7, which is going to be equal to 175. This is done in order to demonstrate that when we have a fraction, in the case of an inverse variation, and we are going to be dividing, we are going to invert and multiply, so the two numbers will be multiplied by each other. In this case, the 25 is multiplied by the 7, and in this case, m is multiplied by d at the end. This shows that we may multiply the numbers when we are writing the ratios as a fraction, and one of the number is reciprocated. So let us go straight ahead now. It's the same problem that we have with the days. Ratios may also be used in inverse variation. Make sure that the inverse reciprocal of one of the variables is used in the ratio in order to be true to the inverse proportionality. So those are our symbols, the same as we had before. So we're going to write the ratio m to 1 over d, because we are talking about inverse variation. So write the other one, 20 to 1 over 15. So 20 to 1 over 15, because those are our initial values. Write another ratio in which m is equal to 30 and d, the number of days, is unknown. Write the ratios as fractions. Remember that when we wrote those ratios as fractions, those that have a fraction on the left hand, on the right hand side, remember that in this particular situation that we have, what will happen? The 15 is going to multiply by the 20, and that is going to give 300, and the d is going to multiply by the 30, and that is going to give 30d. That is what we discussed on the previous slide. So by transposition, d is equal to 10. And of course, the other part of the problem, how many men will complete the task in 42 days? This is the same what we have here, our initial ratio, and we know what that is going to give us. So write another ratio in which d is equal to 42 and m is unknown. We know that this is going to give us 20 times 15, and this is going to give us 42m when we write those ratios as fractions. So write the ratios as fractions, and then we're going to equate them and find the value of m. And that is very simple. M is equal to 7.1, that we round up to 8 men. This will be written as 8 men. I hope that there is no surprise when the fractions turn out to be whole numbers. In fact, in all these cases, the denominator is 1. It's our inverse variation problem that we solved some time ago, and we're going to be using ratio to solve that. So what do we do? Y to 1 over x squared minus 1. That is our ratio. Y to 1 over x squared minus 1. And that's what we have right there. Now, we are going to be using y is 15 and x is 3. Of course, this may be simplified. We know what 3 squared is. and we know what 9 minus 1 is. And of course, what is our other ratio? Find x when y is equal to 5. So y is equal to 5. And that is our situation. We do not know x. So let us write the ratios as fraction, in which we're going to have 8 times 15 and 5 times x squared minus 1. So when we write them as fractions, we're going to get 5 times x squared minus 1 is equal to 8 times 15, which is 120. Clarified on previous slides how we would get a situation like this when we are supposed to write the ratios as fractions. That's what we did on some previous slide ago. And of course, as usual, we are going to transpose, and the value of x is plus or minus 5. And we are going to find y when x is equal to 2. So we are going to use our same 15 to 1 over 8, and we are going to use that right there also. Y is equal to 1 over 2 squared minus 1. Y to 1 over 2 squared minus 1. And that's our situation. So we are going to have 8 times 15 when we attempt to write those ratios as a fraction. And of course, this one we are going to have 3y. So 3y is equal to 120 and y is equal to 40. The power of ratio as a mathematical device cannot be underestimated. Used properly, it can simplify a lot of problems.